Chapter 1. Introduction to Azure Application Gateway. Azure Application Gateway is a web traffic load balancer that enables you to manage traffic to your web applications. Unlike traditional load balancers, the Application Gateway operates at the application layer, which is layer 7 of the OC model. This allows it to make intelligent routing decisions based on the content of an HTTP request, such as the URL path or the host header. It offers various features including URL-based routing, session affinity, web application firewall integration, and of course, Secure Sockets Layer or SSL termination. Azure Application Gateway is a fully managed service, meaning Microsoft handles the maintenance, updates, and scalability, which simplifies the deployment and management of enterprise-grade web applications. Chapter 2. Understanding SSL and HTTPS. SSL, or more accurately its successor TLS, is a cryptographic protocol that secures data transmitted over the Internet. When users access your website using HTTPS, they expect that their data is encrypted and safe from interception. This encryption ensures that sensitive information such as passwords, credit card numbers, and personal details cannot be read by malicious actors during transmission. SSL certificates play a vital role in this process. They are issued by trusted certificate authorities and serve to both encrypt the connection and authenticate the identity of the website. Without a valid SSL certificate, browsers will warn users that the site may not be secure, which can lead to loss of trust and traffic. Chapter 3. SSL Termination Explained. SSL termination is the process of decrypting incoming SSL encrypted traffic at the load balancer level, rather than on the back-end servers. This means that the secure connection is terminated at the Azure Application Gateway, which handles the SSL handshake and decryption. After decryption, the gateway forwards the plain HTTP traffic to the back-end servers. This approach has several advantages. First, it offloads the computational burden of SSL processing from the back-end servers, improving their performance. Second, it simplifies certificate management, since SSL certificates are only required on the gateway. Third, it allows the gateway to inspect and route traffic based on the content of the HTTP request, which is not possible with encrypted traffic. Chapter 4. How Azure Application Gateway Handles SSL Termination. When you configure SSL termination on Azure Application Gateway, you upload your SSL certificate to the gateway. This certificate must be in the PFX format and include both the public and private keys. The gateway uses this certificate to decrypt incoming HTTPS traffic. You can also configure multiple listeners on the gateway, each with its own certificate and associated back-end pool. Once the traffic is decrypted, the gateway can apply rules for routing, rewriting, or firewall inspection. The back-end servers then receive the traffic as plain HTTP. If you need end-to-end encryption, you can also configure re-encryption between the gateway and the back-end servers. In this setup, the gateway terminates the incoming SSL connection, inspects and processes the traffic, and then re-encrypts it before sending it to the back-end. Chapter 5. Security Considerations and Best Practices. While SSL termination offers performance and management benefits, it also introduces a potential security concern because traffic between the application gateway and the back-end servers is unencrypted by default. To mitigate this, you can place the back-end servers in a private virtual network and use network security groups or firewalls to restrict access. Additionally, if data sensitivity requires it, enable SSL re-encryption to maintain secure communication throughout the path. You should also ensure that SSL certificates are managed properly. Use certificates from trusted providers, and set up reminders to renew them before they expire. Consider using Azure Key Vault to manage and store certificates securely. This ensures centralized control and automated renewal when integrated with Azure App Gateway. Chapter 6. Use Cases and Real-World Applications. SSL termination in Azure Application Gateway is widely used in enterprise scenarios where performance and scalability are critical. For example, e-commerce platforms that require high throughput and fast response times benefit from offloading SSL processing. Organizations that deploy multiple applications behind a single gateway can simplify routing and security management using a centralized gateway with SSL termination. It is also common in microservices architectures where many small services reside behind the gateway. SSL termination allows traffic inspection and routing to individual services without needing to manage certificates for each one. Additionally, it's a key component in hybrid cloud setups and scenarios requiring compliance with security policies and data protection regulations. Chapter 7. Conclusion. Azure Application Gateway, with its SSL termination feature, provides a powerful, scalable, and secure way to manage traffic to your web applications. By decrypting SSL at the gateway, it improves back-end performance and enables deeper inspection and routing capabilities. However, It must be implemented with careful attention to network security and certificate management. When used effectively, it becomes a cornerstone of a modern, resilient cloud architecture. Chapter 8. Troubleshooting SSL Termination in Azure Application Gateway. Even though Azure Application Gateway simplifies traffic management and SSL offloading, issues can still arise, especially during initial setup or certificate updates. One of the most common issues encountered is the 502 bad gateway error. This often happens when the application gateway is unable to connect to the backend pool or when the health probe fails. In the context of SSL termination, this can occur if the probe is not configured to match the backend protocol, especially when switching between HTTP and HTTPS. Another frequent issue is related to SSL certificate mismatch or expiration. If the certificate uploaded to the gateway has expired or is invalid, incoming HTTPS requests will fail to establish a connection. Always ensure that the PFX certificate file includes the private key and is protected with the correct password when uploaded. Additionally, if SSL re-encryption is configured but the backend server does not support or accept the re-encrypted connection, you'll run into connection reset errors. It's important to ensure that the backend servers are configured to accept HTTPS traffic if re-encryption is enabled. You should also verify that trusted root certificates are installed on the backend instances when mutual authentication is involved. To troubleshoot effectively, use the diagnostic logs and metrics provided by Azure Monitor. Accessing application gateway access logs, performance metrics, and the diagnostic settings can help pinpoint whether issues stem from SSL processing, routing rules, backend health, or listener configuration. Chapter 9. Integrating Azure Key Vault with Application Gateway. Managing SSL certificates can be complex, especially at scale. Azure Key Vault simplifies this by allowing you to securely store and manage your certificates in a central location. Integration with Azure Application Gateway makes it possible to automate SSL certificate retrieval and renewal directly from Key Vault, reducing the risk of expired certificates and the operational overhead of manual updates. To begin integration, the application gateway must be assigned a managed identity. This identity is granted access to the specific key vault that stores your SSL certificates. In Azure Key Vault, you create an access policy allowing the application gateway to get secrets or certificates, depending on the configuration. Certificates stored in Key Vault must be in the appropriate format and properly tagged for use. Azure automatically detects certificate updates in Key Vault and refreshes them on the application gateway. This means if you rotate your certificate in Key Vault, the new certificate will be picked up by the gateway without requiring downtime or manual intervention. It's essential to monitor the certificate renewal process and validate that automated updates are working as expected. Regular audits of access policies, logging usage of certificates, and setting expiration alerts within Key Vault are also good practices to maintain secure operations. Integrating Azure Key Vault with Application Gateway is especially valuable in enterprise environments where certificate rotation must comply with security policies and where reducing human error is a high priority. This combination enhances both security and efficiency in handling SSL termination at scale. Chapter 10. Best Practices and Step-by-Step Walkthrough for Key Vault Integration. Successfully integrating Azure Key Vault with Application Gateway requires a balance of security, automation, and clarity in configuration. By following a structured approach, you can ensure your certificates are handled securely and efficiently, minimizing downtime and avoiding manual errors. The first step in this process is to create a key vault if you do not already have one. This vault should reside in the same region and subscription as your application gateway for optimal performance and compatibility. Inside the key vault, import or generate your SSL certificate. Ensure it is stored as a certificate object and not just as a secret. The certificate must contain both the public and private keys and should be set up with automatic renewal if you are using certificates issued by Azure or a partner CA. Next, enable Managed Identity for your application gateway. This allows it to authenticate with Azure services, including Key Vault, without needing credentials stored in code. Once Managed Identity is enabled, go back to the Key Vault and create an access policy. This policy must give the application gateway permission to get and list certificates. These two permissions are essential for the gateway to retrieve the certificate and keep it updated. With permissions set, configure your application gateway's HTTPS listener to reference the certificate in the Key Vault. Instead of uploading a PFX file directly to the gateway, you now provide the Key Vault ID and the secret name of the certificate. Azure takes care of the rest. It will automatically fetch the certificate from Key Vault and bind it to the appropriate listener. It is also important to monitor the status of this integration. Azure provides diagnostic logs and alerts that can notify you if the certificate fetch fails, if permissions are insufficient, or if there's a mismatch in expected certificate formats. Set up alerts in Azure Monitor to keep track of expiration dates, renewal status, and error events related to certificate access. From a security perspective, always use the principle of least privilege. Only grant the necessary permissions to the application gateway and keep your key vault's access tightly controlled. Rotate access keys and audit logs regularly, and consider enabling soft delete and purge protection on your key vault for added security. In summary, the integration between Azure Key Vault and Application Gateway allows you to simplify certificate management, increase automation, and strengthen your application's security posture. When set up properly, it can run quietly in the background, managing the critical task of SSL lifecycle management while freeing up your time and reducing the risk of service interruptions. Chapter 11. Zero Downtime Deployment Strategies Using the Application Gateway. In modern web applications, maintaining high availability during deployments is a crucial requirement. Downtime, even for a few seconds, can result in lost revenue, broken user experiences, and a damaged reputation. Azure Application Gateway, when used strategically, plays a key role in enabling zero downtime deployments. The cornerstone of this strategy is blue-green deployment. In this approach, two identical environments are maintained. One live, known as the blue environment, and one idle or staging, called the green environment. Traffic is initially routed only to the blue environment through the application gateway. When it's time to deploy a new version of your application, it is released to the green environment while the blue continues to serve users without interruption. Once the green environment is fully deployed and verified, you update the routing rules in Application Gateway to shift incoming traffic from blue to green. This switch happens instantly and without downtime. If an issue is discovered, you can roll back quickly by directing traffic back to the blue environment. Azure Application Gateway's URL-based routing and host-based rules make this redirection seamless and efficient. Another key deployment technique is canary releases. This involves deploying the new version of the application to a small subset of back-end servers and routing a small percentage of traffic to them using the application gateway's weighted back-end pools. By gradually increasing traffic to the new version, you can monitor performance and behavior in real time. If any anomalies arise, you simply route traffic back to the stable version with minimal user impact. Health probes are another critical component in zero downtime strategies. These probes, configured within the application gateway, constantly check the availability and responsiveness of back-end servers. During deployments, health probes ensure that only healthy instances receive traffic. If a newly deployed instance fails the probe, it is immediately removed from the active pool, preventing it from affecting users. To enhance reliability further, you can combine Azure Application Gateway with deployment tools like Azure DevOps or GitHub Actions. These tools allow you to automate deployments, stage rollouts, and run pre- and post-deployment tests. They can trigger updates to routing rules or back-end pools in the application gateway as part of the deployment pipeline. In scenarios with multiple regions or availability zones, Azure Front Door can be layered in front of the application gateway. This provides global failover and latency-based routing, ensuring that users are always directed to the closest healthy instance, even during regional updates or outages. Finally, always monitor deployment performance and user experience. Use Azure Monitor and Application Insights to track metrics such as response time, error rate, and user behavior before, during, and after the rollout. These insights help you fine-tune your deployment process and catch issues before they escalate. By leveraging strategies like blue-green deployments, canary releases, health probes, and automation, Azure Application Gateway empowers teams to deploy confidently, rapidly, and without disruption. With careful planning and smart configuration, zero downtime deployments become not just possible, but routine.